trees.
Are there extremophiles existing today on Earth that could potentially colonize some of the more habitable regions of Mars?
No, unfortunately, there is no environment we know on Mars and no organism we know on Earth at the present time in which something from Earth could grow. So there's a minimum amount of warming that must be done before even these very hardy alpine and polar microorganisms can grow. So right now, nothing from Earth can grow anywhere on Mars. Things from Earth could be dormant and could survive on Mars in a frozen, non-growing state, but nothing could grow. So the first step to making Mars biology rich is pushing it a little bit so that it becomes warm enough so that it's just within the scope of these very cold adapted organisms. And that's still a little bit warmer than it is now.
It appears that we do know what type of organisms we will be taking with us on Mars. Do we know what we don't want to take from here from Earth? And I'm talking from a biosecurity perspective now.
Well, on my list of organisms that we don't want to take are mosquitoes. Other than that, I really haven't given that much thought. We're much more constrained by what can grow than by what we don't want to bring. So it's a good question, but we really haven't thought very much about that.
And so luckily it appears to have already a natural selection and the organisms to be defined by the temperatures in which they can grow.
That's right. And the composition of the atmosphere, for a long time, it will be very low in oxygen. So it will, there'll be selective. The environment will constrain what can grow and what.
So your Spaceward Bound program is teaching students to research all aspects of space exploration and the biology of space organisms, I guess you could call them. Do you want to tell us a little bit more about how Spaceward Bound works and the kind of things you're trying to do?
Yeah, happy to. We have been doing these expeditions to cold and dry Mars-like environments for a long, long time. And about 5 years ago, we started a new phase of the project called Spaceward Bound, where we started bringing teachers, science teachers, and also students, but mostly teachers, with us in the field. And we didn't really change what we were doing in the field. We're still doing science expeditions, still doing research, but now we just recruited the teachers essentially as free labor. And we put them to work helping us do our field research. And to my surprise, the teachers loved it. And the other scientists loved having the teachers involved because they asked good questions. And then what the teachers were able to do is take this experience of doing science in the field and turn it into curriculum for their students. So we've gotten very positive feedback on this whole activity, and we're going to continue to do it. We just did a big expedition in Australia up to the Pilbara region, to the oldest rocks with evidence for life on Earth. And we had teachers with us. It was a science-driven expedition, but the teachers came along, and it's a good example. We'll do another one in the Mojave Desert in March, and another one in the Namib Desert in April. So we will continue to do these expeditions, and we'll continue to involve teachers and students. It seems to be working very well.
Who can participate in such events?
Well, we've had teachers from all over the world be involved. Whenever we do expeditions in a particular country, we try very hard to get teachers from that country involved. So, for example, if we came to the hot springs in the North Island, we would work hard to recruit teachers from the nearby cities like Wellington or whatever and get them to come out because it's local and get them to appreciate the environment which they are near, which is very relevant for astrobiology. The hot springs on the North Island is a perfect example. It's a place that scientists come from all over the world to study because of their relevance to understanding thermophiles and life in extreme environments and possible subsurface life on Mars and Europa. So if we were to do an expedition there, we would put out a call to bring in teachers from the local schools, from the local area, to be involved and come out with us to do the research.
And we are looking forward to seeing you here, and we're looking forward to seeing you all over the world, actually.
I enjoy it.
Are we still discovering new things about thermophiles and extremophiles, or do we really know pretty much everything there is to know about them?
No, we are still discovering new things about life in environments. We are working, for example, in very high elevations in Antarctica. and we're finding organisms and investigating organisms that are growing when the warmest temperature they ever see is minus 15. And we're learning new things about how those organisms adapt and survive. And it's pushing the limits of our technology to be able to even measure their growth rate. They grow so slow. So there's two things that are constantly changing. One is, as we go to these new environments, we find new examples of organisms to study. And the second, possibly even more important, is biotechnology is advancing so rapidly. New genetic and metagenomic techniques are being developed that we can go back to places that we studied 5 years ago with tools that are completely revolutionary compared to what we had just 5 years ago. It's almost dizzying trying to keep up with that technology that's being developed in the biomedical area. And we can apply it to our studies of life in extreme environments and really get a lot of deep understanding. And I'm excited because those are the same tools we'll want to apply to study life on Mars when we ever find it. The places that are my favorite are the Atacama Desert and the dry valleys of Antarctica. And the Atacama Desert is probably, almost certainly, the driest place on Earth. And it's the one place where we have found that we have crossed the border between wet enough for life and too dry for life. It's the only place on Earth where we can go to a place and say, this zone is too dry for life from Earth to survive. No other desert do we really see that. For example, the deserts in Australia, we've gone to the driest part of the deserts in Australia, and there's still plenty of life there. It's not very good for raising crops or cattle, but in terms of the kind of life that we study, it's quite habitable. Only in the Atacama Desert do we find conditions, do we cross that line between life and no life, too dry for life. And so that, to me, is why it's so interesting, because when you go into that environment, you really see very different processes. You see a very different landscape, in a sense. If you know what you're looking at, you see a lifeless landscape, a landscape of alien world without life. And the really amazing thing is it's only an hour and a half from a major airport on good road. You can fly into Antofagasta and rent a car and drive to the driest place on Earth in an hour. The other interesting place for me is the dry valleys of Antarctica. And here we find an environment that is probably the best analog for Mars in being cold and dry. And so there we get, I think, the human feeling of how it must be to be on Mars. So cold, so dry, so alien.